What's going on? This is the fourth video in the Linux or the Red Hat Linux Enterprise Training course. In this video, we will talk about file linking. So file linking is a concept where you can link files together or directories together. It is similar to copying, but there are vast differences between copying and linking. We're going to talk about this, soft links, hard links. Okay, before talking about file linking, let's first look about file attributes or metadata. So every file in Linux has type, size, permissions, owner, and group. So all this metadata, in addition to the last access time and last modified time, are called the metadata of the file or directory. And this metadata is stored in 28-byte storage. The 128-byte storage called the inode or the index node. The index node is a unique number assigned to every file that includes the metadata. So for example, an example index node number is, say, 1, 0, anything 7, 6, 1, 4, 7. This is an example of inode number. Inode number. Inode number are uniques. Okay, so basically every file has a different inode number, and inode number are used to link or are used by the kernel in Linux to access the file metadata and to just handle the file. So links or file links. File links are created either between file to file or directory to directory. They cannot be created between file to directory or directory to file. So it is not bidirectional. So what are the link types? We have hard links and we have soft links. Let's talk about each one of these. So the hard links, when you create a hard link between, say you have, say you have file 1 or 01, file 02, txt, text file, text file. So when I create a hard link from file 01 to file 02, where file 02 will be the shortcut or will point to file 01. So file 01 is, say it is the original, and file 02 is the link. So file 02 will link to file 01. So when I create the link, which is file 02, it will have the same inode number. We will demonstrate this in the lab section. It will have the same metadata. Changes are bidirectional. So any change you do here on the contents, on the name, not the name, the content, if they change the content of the file, it will be, the changes will synchronize to file 01. Deleting either files will not affect the other. It means that if I delete the original file, okay, I will still be able to access the file 02, okay, and see its contents. The same applies if I delete the file 02, which is big F, I will still be able to access the contents or the file 01. That's the key difference between the hard links and soft links. Now in soft links, inode numbers, see the links, this link file or the links are shortcuts. So let's get back to the example. So file 02 here will be only a shortcut to file 01, much like shortcuts in Windows. Okay, so for example, I have original file called file 1, and file 1 has file 2, file 3, file 4, links. Oh Jesus, what's that? Let's delete this one. It's all messed up now. Okay. So let me demonstrate this one more time. So let's say we have file 1. File 1 has file 2, file 3, file 4. So soft links, if you create these files as soft links, they will point to the same location, okay? But the inode numbers will be the same, or will be different. So inodes are different, and at the same time, when inodes are different, it means that the metadata, the owner, the permissions, the last time modified, the last time accessed will be different between the links and the file, original file. At the same time, if you delete the original file, the shortcuts will be invalid. So basically here, deleting the original file renders the links invalid. Changes are also bidirectional. So the key difference between soft links and hard links, first, the delete. If you delete the links, soft links, in soft links, if you delete the original file, the links will be affected. In hard links, if you delete the original file, the links will not be affected. Other than that, you don't have to worry about other stuff, other than the inode numbers and the metadata will be different. Now, you may ask me, what's the difference between linking and copying? So when you copy a file using the cp command, okay, and when you link a file or use soft links or hard links using the ln command, what's the difference? So the first difference is the changes. The changes in or when creating links are, as we said earlier, bidirectional. If you change the link, the original will change and vice versa. But in copying, no. If you create file 1 and copy that to copy file 1, create a copy of file 1. If you change the copy here, the file 1 will remain intact. That's a key difference. Location. So in copying, you can choose to put the location of the copied file wherever you want. But in linking, the link will eventually link to the same location of the original file. Accessing from different locations. What do you mean by that? So in linking, we can create many links to the original file and we access them from different locations, right? Okay, but we use links when we want to edit on the source file, okay, from different locations. Say, for example, the original file is in home, okay. Now I create a link in root and link in opt, link in share. So if I am on share or opt or root and I want to modify on the file on home, I can just modify on the links. That's what I mean by accessing from different locations. But copying files, this is not the case. If you have a copy in home, okay, and you make or you created different copies in these directories, if you change one of these, okay, the changes here will not be reflected on the original file. So you will not use copying if you want to change on the original file from different locations. Now, permissions, most important. So the permissions of when you copy a file, the permissions on the copied file are different from the original file, but in the links, they are the same. Let's examine all of that in the virtual machine or in the lab. Okay, so let's create a file called touch file or touch original. And change on that file or echo some text. This is the original file. Get original. Okay, now I want to create a hard link. Okay, creating a hard link can be accomplished by using ln, the name of the original file, which is original, and the name of the link that will be created. So I will say hard link original. ls So as you can see, I created now the link, the hard link. If I cut the content, you'll see it's the same. All right, let's examine the permissions, the inode numbers. Okay, so this is the original file and this is the copied file, the link file. As you can see, this is the inode number. The inode numbers are the same and the permissions are the same. Okay, as you can see, 2 indicates the number of links. So since original links to HL original and vice versa, the number of links is 2, right? So as we said earlier, hard links is creating an identical version of the original file. So if I change now on HL original, let's say echo added text to hard link. Let's append them to the HL original, cat HL. So this is the new text. Let's examine now the changes on the original file, which is original. So cat original. As you can see, the changes are replicated. Now, if I delete original, let's delete original, rm-f original. And let's see, you can still access the linked file. So cat hl, as you can see, the content remained intact. That's the hard links. Now let's create a sample for demonstrating the soft links. So let's say, let's create the same file one more time. Okay, now let's create soft link. Soft link can be created by issuing the command ln-s, the name of the original file, and the shortcut soft link original. Okay, let's examine the contents. Cat soft link, the content is the same. Let's examine the inode numbers and other metadata. IL. Okay, so what makes soft link linking different from hard link is, as you can see, this in the soft link, there is a pointer or a row from the link or the shortcut to its original file, indicating that this is merely shortcuts. And as you can see, there is a letter here, indicating that this is soft link. Inode number is different from the original file, right? Okay, now let's make some changes on the SL. So echo changes pertinent to soft link. SL original, cat SL. So changes on, we have changed the, or we added some text to the soft link. Let's examine the original file, cat original, and the changes were replicated. Now if we delete the original file, rm-f, as you can see, the color of the file has changed. It's in red now, indicating that the file is invalid. So ls-l, see here, the soft link here indicates or links to a non-existent file because we have deleted the original file. If we cat sl, you see no such file or directory. The soft link is rendered invalid. That's the key difference now between soft links and hard links, or linking in Linux. Okay, so that was about today. I hope you enjoyed that and see you in the next video.